Hey, hello, and welcome. Today we're going to be talking about Dexie.js for offline data storage in React applications. My name is Ebenezer. I'm a developer advocate for web and JavaScript, and we're going to be learning how to use Dexie.js with this application, this to-do app. Now, this is a to-do app, and let's do something awesome today. Our to-do application persists data on the browser. So we are using IndexedDb, a database in the browser, to persist data so that no matter how many times we reload our page, we are always going to see our data there. And to get to access IndexedDb on your browser, by the way, I'm going to be leaving a link to this project and the code base in the description of this video. So check it out right now, so you can follow along. So you inspect and go over to application tab. And right here we have IndexedDb. You can see the to-do app, the database for this application. And look at what we have here for this particular to-do. Do something awesome today. The data is already right here. Do something awesome today. I'm just going to zoom in so you see that better. So right here we have do something awesome today. Right now the completion status is false, ID 1, and task do something awesome today. So what if we decide to mark this as complete? We're done doing something awesome today. So look at right now, data may be stale. We'll have to refresh this database and do something awesome today. Completed true, ID 1, and task do something awesome today. And we reload, we come back to this page, we are always going to see a data there. And that's the wonder of IndexedDB with Dexie.js in a browser. And this is what we're going to be learning how to do today. We're going to learn how to build this to-do application, and we're going to learn how to use IndexedDB and Dexie.js for storage. Okay, you might be wondering, why not local storage? And what's even IndexedDB? You've probably not heard of IndexedDB before, and that's understandable. First of all, local storage supports only string data. So what if I want to store more than string? What if I want to store images? Maybe I want to take photos today, and I want to store that in my app. What do I do? Or I want to listen to music. I want to put that in my app. What do I do? So if I want to store more than text, that's going to be a problem because local storage supports only string data. Local storage has this 5 MB limit across major browsers. So what if we want to store something more than 5 MB? That's going to be a problem. Local storage is also vulnerable to XSS attacks. So it's easy for any JavaScript code to access our local storage data. It's synchronous. So with local storage, you can only do one thing at a time, and that can be really slow when you start working with large applications. So, well, local storage might not be the best choice for you. If you want to avoid, if you don't want string data, if you want more than 5 MB limit across major browsers, maybe more security in terms of XSS attacks. Even though there are ways you can also prevent these XSS attacks with local storage. And, you want to work with large code base, large application, and you want something more than synchronous support. You want asynchronous support, for example. And this is why we have IndexedDB. So IndexedDB on the browser, which I've already shown you an example in this to-do application. I'm also going to be leaving the live URL link to this application so that you can just open it, go over to the description of this video and you can just click on it, open it, and you see what we're talking about right here. So you can add a task and you see your task right here. So this is IndexedDB in action. So why IndexedDB? Firstly, IndexedDB is asynchronous. Unlike local storage, which is synchronous, IndexedDB is asynchronous. So we can work better with large applications using IndexedDB. In terms of speed too, and storage limits depends on users' disk space. So unlike local storage, which has just 5 MB storage, it can store multiple data types. Also with IndexedDB, we can store images, array buffers. You can use that to store music. We can use that to store objects, arrays, multiple data types, unlike local storage, which is just string data. And IndexedDB is structured. With IndexedDB, we can specify the structure of our database. We do this with object stores, which we're going to talk about as we dive into the code for our application. Data can be queried and filtered. So in our application, I can take you through our code base right now, and you see examples. Don't worry if this looks foreign. We're going to do this from scratch. We're going to build this together, especially the IndexedDB and Dexie functionalities. So add task right here, data can be queried. For delete task, we can get the particular task using ID, and then we can delete that task. We want to update the task, toggle the status. We can use the update method to get that particular task with the ID and then update that task. We're going to do this together, so don't worry. Data can be queried, data can be filtered, and it can only be accessed by the same origin. So that's helps prevent XSS attacks. So if I'm in the origin of, let's say, localhost 3000, like only localhost 3000 can access my IndexedDB database. Localhost 4000 cannot access it. YouTube.com, if my IndexedDB database is on YouTube.com, only YouTube.com can access it. Facebook.com cannot access my database. Twitter.com cannot access my database. So it can only be accessed by the same origin. Now, why not IndexedDB? IndexedDB is not supported on some legacy browsers, like i.e. Internet Explorer, old versions of Internet Explorer, old versions of Opera Mini, right? Opera Mobile or Opera Mini. It's not supported on some legacy browsers. It's supported on the newer versions of the browsers like Chrome, Firefox. It's also not supported on Firefox Incognito currently. But that's probably going to change in the future. It can be complex to use. So just IndexedDB can be complex to use. And don't worry about complexity. That's actually why we have Dexie.js. Now, poor queries with just IndexedDB, you have poor queries. It's not so easy to query your database, filter through and all that. But again, that's why we have Dexie.js. This is the support table for IndexedDB. You can see Internet Explorer partially supported for version 11 and 10, not supported for 9 and 8. Now, this table is from W3CUB docs. So that should be W3 Corp docs. Now that we know that IndexedDB can be complex, and I've explained to you that this is why we need Dexie.js. This is why I use Dexie.js to work with IndexedDB. Dexie.js is a minimalistic wrapper for IndexedDB. Dexie.js makes working with IndexedDB really easy. Like, is as easy as filtering, for example, or querying a database. Is as easy as calling your database db.friends where age is above 75 right here, and then converting that to array. Creating a database is as easy as this. With just IndexedDB, this is complex, but with Dexie.js, I'm creating a database as easy as this: new Dexie, my database. And that's it. You have a database named my database, db.version1.stores, to declare an object store, a table, for example. And you have friends. This is called object store. These are called object stores in IndexedDB. Friends right here. And then this is where we're defining the structure of friends. You have ID, you have name, and you have age. Now, before we dive right into WebStorm for a code, here's the link to the code base and the base app template. So we have a base app we're going to start with. You'll also find these links in the description, so you don't have to type it out. You just go back to the description of this video and you can click on that link, and those links, you get the link to the complete code base, you get the link to the base app template. So we're going to start with the base app template, which contains the design of our to-do app already, so we don't have to start struggling with design. We just focus on what's important: IndexedDB, Dexie.js, React.js. Let's get started. Hey, you're right. Let's start by going to this URL, github.com/ebenezerdon/to-do app React template. Links in the description, remember. Now, want to hit this use this template button, and then we should get a version of this template repository in our own GitHub account. So you can choose a repository name, description, public or private, or that's optional. Or you can take this URL and then come over to WebStorm and hit this get from VCS button, and we click and we paste the URL inside this URL box. Hit clone directly, and we should get a clone of that repository, which we can start with. Next thing you want to do is hit run npm install. And with that installed, what we want to do next is come over to the npm section of WebStorm, or we can go over to a terminal if you're using a different IDE than WebStorm. And then you want to run npm install, or double click on the start button right here on the left pane. And this is what we have right here for our template application. So this is the to-do app. We already have static data right here, which really does nothing. We can add data to application, add something, and hit the add button. Nothing happens. So what we're going to do is use Dexie.js, IndexedDB, and React to make this to-do application work, so that we can add data to a database, add items to our to-do list, and we can see it right here. We can mark as checked, or don't mark as checked, mark as unchecked. We can also delete and all that, which we can do right now in our application. Now let's go back to WebStorm and see how we can make this work. Back to WebStorm, you can see that we have the src directory right here in the project explorer. When we open that up, we can go over to the app.js file, and we start by importing React from React and a CSS file app.css. Now for this application, we're using Materialize for styling. That's why you can see right here on line 6 we have class name as container, till text center line. That's just to make the project easy for us, so we can just use Materialize for styling, and we use CDN for Materialize in case you want to go through this project and understand how things work. Over to the index.html file on line 6 right here, you can see where we're using the CDN for Materialize, and you might want to install this download this library in your WebStorm IDE by hovering on this link and then hitting the download library button, and that should give you auto suggestions when you're trying to call the when you're trying to use the Materialize classes. Now back to our app.js file, we have the div container, and first of all we have h3 for to app, that's the text right here, and we also gave it the class name to text center line for styling, and then we have a form, we have the input fields which we want to use to add items to our to-do application. So right here we have placeholders, what you want to do today, which you can see right here in the application, and you have the button for adding a to-do item, and this is an example of a to-do item. So first of all, we have a row on line 22 for each of the items. So this is row, and right here on line 25 we have label with type checkbox, and by default this is checked just to show you what it's going to look like when checked. And for every of our completed items, we're also giving it the strike text class. That's so that you know that this item has been completed, and we just strike through it. So we have on line 32 again another row which is do my laundry. Right here on line 32 you can see the text right here on line 36 for do my laundry, and same explanation with the first one, call John Legend. All right, for our application, if we come over to package.json, you can see the dependencies we're using right now: just React, React DOM, and React scripts. Right now we need to install Dexie in our application, so we'll come over to the terminal and want to run the command npm install. Actually we are using yarn for our project, but you can use npm if you want. So yarn add, and we want to add Dexie, the package Dexie. We also need Dexie React hooks, and I'm going to explain what Dexie React hook does in a second. So this is Dexie React hooks, and hit enter. So we're going to use Dexie React hooks to watch for changes in our database, in our IndexedDb database, and you see how that works. Right now we have Dexie and Dexie React hooks installed. We have version 3.2.2 and 1.1.1 for Dexie and Dexie React hooks respectively. Back to app.js file, I want to close this project directory so that we can see what we're doing clearer, and I also zoom in to make it easier for us to read what's on the screen. Now in app.js, the first thing we want to do is create a database. And with Dexie.js, it's easy to create an IndexedDB database. All we need to do is declare a variable const db. You can name it whatever you want to name it, and then new Dexie. So we want to get Dexie, and right here we have this prompts from WebStorm missing import statement. Insert import Dexie from Dexie, and we have our import right there. We want to also give our database a name. So this is the database name, and there are people who get confused sometimes when using a WebStorm, when watching a WebStorm video tutorial, because you feel like writing this text database name, but this is not part of the application. I didn't write database name. This is just WebStorm telling us that this to-do app right now, this text to-do app, is the database name. So you don't have to write database name. You're going to get those quickly write lines in your IDE or editor. So this is just new Dexie. You have your parentheses and the string to-do app. And we have a database right there. We can now use a database. So db.version right now, we want to specify the version for this database. And right now, this is version 1. I'll tell you why we need to specify version for a database in a bit again, but this is version 1.stores. And this is to create remember I explained object stores. They're similar to what you might know as tables in other data bases. So this is the object stores, and we have to choose right here as our object store. Remember, I want to add like to-do items, and this is the structure of our database. I showed you a bit of this in the complete code base before. So we have ID, and then we have task. We're going to separate each of these items or each of these fields with the comma. So ID task, and completed, the completed status. Now we're using ++ for ID. This is for auto incrementing with Dexie and IndexedDb, so that we don't need to specify our ID when adding data to a database. When adding to-do items, we're just going to get auto incremented IDs for our database object store to-dos. Now the version number, version 1, is here so that our application knows what version this structure of a database belongs to. If we run this application right now, we open up this application in a browser we've created, so in a browser, and Dexie JavaScript helps us create this database in the browser, and then want to come back to our application and modify the structure of this database. Let's say instead of just ID, task, and completed, we need date. Want to add date right here, and want to add something else, just something random like music or so. We'll need to increment the version number. So this is going to return an error for us if we try to run this again after we've run it before, after the database has already been created. So to be able to modify the structure of our database after the database has been created, we'll need to update this version number, and we can only increase it. So it can only be increased, so from 1 to 2, from 2 to 3, from 3 to 4, and so on and so forth. So we can't go from 1 to 0, we can go from 4 to 3. It can only be increased, and it can only be whole numbers, so not 1.5. It has to be 1 or 2 or 3 or 4 or 5. And that's for our DB version right there. That's for creating a database. We successfully created a database, and we're going to see what this looks like in a bit. Now here's something I like doing. I want to get to-dos for a database. Normally, to get to be able to fetch stuff from a database right now that we've created it, we can just do this db.todos.toArray, and this is us getting every to-do item in a database and converting it to array. But before we do that, before we go to the, that aspect, I want to destructure to-dos because we're going to be using it in multiple places. Let me get that from DB, so we can just call to-dos instead of db.todos. Now on line 12, I want to create a new line here, which we're going to use for all our items, and this is const all items right here. So we're declaring a variable named all items, and this is where we're going to use live query. So you can see WebStorm is giving us that prompt, use live query, and we're going to import use live query from Dexie React hooks, and this is our function inside of use live query, and it returns todos.array. So todos.toArray. Remember, I talked about how we're going to fetch data from a database from our to-dos object store, and this is us getting our to-dos in an array form. And our use live query method also expects a dependency array. With this use live query, our React application is going to be able to watch the data in a database, see when we've added something to a database, to this all items to-dos object store, see when we've removed something, see when we've updated the database, and then it's going to re-render a component with the new data. So that's what we're using use live query from, and we can add dependencies that are going to help us watch for changes in this database. And right now we have all our items in a database, but we don't have anything in a database yet. We can still log this to the console and see what it looks like. We also want to see if a database has been created successfully. So let's log all items to the console. And I'm just going to go back to a browser, reload just to be sure, inspect, and go to the application folder right here, the application section rather. And you can see our to-do app has been created for us. Watch this. This is localhost 3001. Remember, we have the completed application, which is localhost 3000. But we can't see that from localhost 3001. We can only see localhost 3001. And this is our to-do app right here. This is our database which has been successfully created for us. This is the structure, to-dos, dates, task completed. Oh, we left date. Okay, now we can close this, and let's go back to application and see how we can add tasks to our database. Now I want to remove line 16, and I want to come over to create a new line 16 and create an add task variable. I want to use this for the add task function, which we're going to call in our JSX code. So this is going to be an asynchronous function, and we are going to expect events when this is being called, so that we can be able to prevent the default reloads. Remember, this is a form. Okay, so I'm just going to comment that out, and then we don't have the error anymore. So remember, this is a form that we can add data to with a submit button add. Right now, if we hit the add button, oh, this is input field is needed. So if we hit the add button right now, you see that it reloads. So hey, and add, it reloads a page. So we want to prevent that with the event.prevent default method. So right here we have event.prevent default, and that should prevent the default reload event. Now const task field, we're going to get the task field, and this is document.query selector. So we want to get this field right here so that this keeps happening. I'm just going to comment this out again. Now I want to get this field right here so we'll be able to get the values from the field. Now const task field is equal to document right here dot query selector, and what's the ID for this particular field. So let's go look for the field. This is the input field right here, and we don't have ID right now, so I'm just going to add an ID after type, and this should be task inputs right here. So task input, and we can come back to line 18 and document.query selector, let's get task inputs. So this is task inputs, and just to be sure we done everything correctly. All right, we can log this to the console so that we know what we're doing. So this is task field right here, and we want to get the value of task field. So task field.value, and next thing we want to do is call task field. So when we click on this button, we can have we can use an onSubmit function here, or we can add that to the button also. So let's just do that with the form onSubmit right here, and onSubmit attribute rather. So onSubmit right here, and what do we want to do on submit? Add task. We want to run the add task function. So onSubmit right here, add task. Now let's save this and see what happens when we try to submit in our application. Now this is our application, and I want to add a new task. Remember, we've not done anything with the database yet. We want to just confirm if we're getting the task input. So this is the task input, and hit the add button, and look at it right there. So we don't have the default reload, and we have the value of a task. This is the task input. All right, so we can continue back to our code base. Let's remove line 19 and just create line 19 again. Now to add a task with Dexie.js is straightforward. All we need to do, remember, this is an asynchronous function, so we want to await to-dos right here, to-dos which we've destructured from DB. Ordinarily it would be db.todos, but since we've already destructured to-dos, we can just have to-dos.add right here, and this is a function called a method, and that expects an object right here. So this is the task right now. So this is the task you want to add to the to-dos object store. So task right here, and I want to add this value, the value of task field. So this is task field and value, or we can do this, we can do task field dot value. But in case you're using a different ID than WebStorm or some other kind of linting, maybe TypeScript linting, and you're getting an error, you can fix that with this. So task field and then value, so it's still the same thing. And then we have completed, which is false right now by default. We want this to be false. So task field, you have the value right there, task field.value, and then you have completed as false, and this is a task which we're going to add every time we hit the add task button. Now the next one we want to do is clear our input field. So this is task field, and then either task field.value or task fields in square brackets value, and this is equal to an empty string, so that whenever we add a task, we can go ahead and clear our input field. So let's save this, and back to a browser, let's try to add a task to the database. So we're going to go over to the application section and then to IndexedDB. Let me zoom out a bit so we can see it better. And then this is the task input. Let's try to add an actual task. So what do I want to do today? I want to write code today. So write code right here and hit the add task button. So look at this right now. In our application in IndexedDB, data may be still, so which means that something has changed. We hit the reload button, and look at that, we have our new task right here. I should be able to do this. So this is a new task right here. So task write code completed false. So this is the new task. Task is write code, which we just added. We can go ahead and notice that once we add a task, the input field clears, just as we told the application to do. Now what you want to do today, I want to edit videos. So edit videos and add, and look at that, data may be still, we reload, and look at our new task. So write code, edit videos, and that's it for our tasks. Now the next thing we want to do is view these tasks in our application. Right now what we have here is the static data, culture and legend, or do my laundry. How do we view the task we've added to our IndexedDB database in our application? Hey, all right. Now to view our task, we'll need to get remember we've already gotten all items on line 14 right here using use live query. We can also log this to the console just to be sure that we have a task right here. So all items. To view a task, to get a task normally with Dexie.js, all you need to do is call the object store, which is to-dos or db.todos, and then .to. We're going to get all the tasks in an array. So let's log all items to our console right now and see what we have in the browser. So inspect and go back to the console and look at that. We have the two tasks which we've created: write code and edit videos. All right. Now, how do we use this in our application? Now, this is the form section. We're not going to touch it. We're just going to come over to this card content where we have the static data. And what I want to do inside this card content is loop through all items. So this is all items, and we're going to use the map method, all items.map. And let's use optional chaining for this, just in case all items is not available. We don't want to get an error on you cannot access map of undefined. So all items.map right here, we have this optional chaining. If this doesn't exist, don't bother. If all items is undefined, don't bother. So all items.map, for each item right here, we want to return what we have here. So from line 51 to line 59. Let's just select line 51 to line 59, and we can just drag it to line 49. And look at this, all items.map, and for each item give us this. Now on line 49, I want to give each row a key, and we're just going to use the ID of item. So this is item.id right here. Remember, each of our item has ID. And the next thing we want is the completed status. So right here you have checked, and checked is either if it's completed, it should be checked, and if it's not completed, it should not be checked. And checked right now is either true or false. So checked is going to be either what is there or what is not there. So if it's completed, it's going to be true. If it's not completed, it's going to be false. So this right here is item.completed. And we want to break this down so that it's easier for us to see. So take check to a new line and take class name to a new line. And this is what we have right here. The next thing we want to do is update the text for our item. So for each of our item, each of our to-do task, what do we want to do? We don't want to call John Legend anymore. We want to do whatever the user says they want to do. So right here, we're just going to use the item.task. So remember from our add task function, we have task as the whatever the user writes inside of the input field, and then we have the completed status right there. So back to line 57, we have item.task for that. And another way we can do this right now, instead of having item.id, item.completed, and item.task, what you're going to see in the code base, the completed code base, if you go over to it, is you see that I already destructured ID, completed, and task right here on line 49. So to do that is the same thing, remember, so you don't have to do this. To do that, we can just get ID, get completed, and get task on line 48, and then instead of item.id we have ID, instead of item.completed we have completed, and instead of item.task we have task right there. All right, now we can go ahead and remove line 65 to line 73. Now let's take this away since we don't need the static data anymore. So we can save this, and look at that. Look at what we have here. Write code, edit videos. Now let's say we want to do something else. I don't just want to write code and edit videos. I want to push my code base to GitHub. So push code base to GitHub right here and add task. And look at it right there. Push code base to GitHub right there. We're going to see it immediately we add the task. And remember, like I explained this before, this is because we are using use live query to get all of our items. So use live query is helping us watch the database. Whenever we add a new task, our page is going to be updated with the new data. Let's say we want to remove a data, which we're going to see next, how to remove items in a database with IndexedDb and with Dexie.js and IndexedDb. So let's add a new task. Use live query is going to see that we've updated the database, we've updated to-dos, and then we use that new data to re-render a component. So write code, edit videos, push code base to GitHub, send tweets about videos, so send tweets about video, and add task, and look at it right there, send tweet about video. right there, right there, right there. You can see our application is looking good so far. Now let's see how to delete these items. All right, to delete our items, all we need to do is create a delete task function. So after the add task function, I want to create a delete task function right here. So const delete task, and this is equal to this is also an asynchronous function, so async right here, and we need IDs to be able to delete a particular task. We need that task ID, and then all we need to do is to choose .delete and ID, and that's it. That's for deleting the task. So you get the ID and then you use the delete method to delete that task with the particular ID. Now, how do we use our delete task function? We're going to look for the delete button, which is right here on line 62. Now for the delete button, we need the onClick event listener. So on click right here, we might want to break this down so that it's more visible. I'm just going to break this down. On click, we have class name right there, we have delete, and then we have the closing tag for I also want to take the closing bracket on line 64 to line 65 so that it's easier understood. All right, so for the onClick function right here, what we want to do is create a function. So this is an arrow function right here, and then delete task. And what task do we want to delete? Remember, we have the task ID right here, and this is ID. If you did not destructure, you have task, right? This is whatever it was, so either task or to-dos.id. So right now it's ID, just ID, and delete task, that particular ID, and this is what we have right here. So let's save this and see if this works. Now back to our code base. Let's say I'm done writing code and I can just hit this delete button, and look at that, it's out of the way. Use live query helping us again to watch for changes in our database. Let's say I'm done pushing code base to GitHub. I want to delete this, but you can see that right now we've not marked any of this item as complete. We just created this task, we just added this task, so new task right here, and it's already crossed out. So what do we do? How do we fix that? On line 59, you see that we have the strike text class. So we only want the strike text class if the item is complete. So if completed is true, that's when we want the strike text class. Now how do we do that? Let's make this let's use JavaScript to write a text right here. So we'll put this in the curly brackets, and we also want to use the backtick for this so that we can use template literals in a text. And we have the $, we have the curly brace, and then we close the curly brace. So this is strike text right now, and we only want to add the strike text class if this item is completed. So completed and strike text right there. So this is the class name, black-text right here. So black text right here, and then strike text only if this item is completed. Yeah, strike text. If it's not completed, then don't strike text. Now let's see if this works. Look at that. Back to our application, edit videos, send with about videos, new task. All of these tasks are not completed yet, and they don't have the strike text class. Now, what if we want to see the strike text class? We have to be able to mark these items as complete, and that's what we're going to do next. Let's see how to mark items as complete. All right. To mark items as complete, we're going to create a new function just like we created for add task and delete task. Let's name a new function toggle status. So this either marks as complete or marks as not completed. I hope that's the right word. So TOGGLE for toggle status right here, right? And this is also an asynchronous function, so async right here. And we need ID and event. Remember, we want to toggle status, so we need ID to be able to toggle the status. And then we want to do this. So await to-dos.update. To add to-dos.add, this is readable. So to delete to-dos.delete, and to update to-dos.update. We want to update the status. We want to update this completed status right here. So completed right here on line 24. We want to update this to either false or either true or false. So await to-dos.update, and what item, what task do we want to update? So we need the ID for that. So this is ID right here, and then this is whatever task that has this ID, update it to use this object to update that particular item. So completed right here is going to be either true or false. So for that we have not event.target.checked. So if it's true, it's going to be false, and if it's false, it's going to be true. So to just update you give it you give the method the ID as the first argument, and then you have the object. This is what you want to update in that particular to-do item. So completed right here should be, if it's currently true, you make it false, and if it's currently false, you make it true. Now back to our JSX code, we're going to look for this checkbox so that we can be able to call the toggle item status method whenever we click on any of them. So where's the checkbox? You can find the checkbox right here on line 58, and what we want to do is add an onChange method. So this is an onChange attribute right here, and this is a function. Remember, we wanted to pass events to a checkbox, so this event right here, and toggle status ID, and then the event. So this is the ID and then the event. Event is so that we're going to be able to get the checked value. So is it checked, is it not checked? We are going to use that to update the completed field. So this completed is either going to be true or false. If it's currently true, make it false, and if it's currently false, make it true. So let's save this and see what we have in our code base. Let's try to mark edit videos as complete. This is not working right now, and we have a problem. So for toggle status on line 32, we have to use not instead of just not to toggle. So this is not event or target or checked instead of just not event or target or checked. Now let's go back to our code base and try it again. So edit videos. Oh, that's working, and you can see that when the item is complete, when the completion status is true, you know, it's crossed out, and this checkbox has changed to the good sign, to the check mark sign. And then sent with about video, new task. Can we delete a task? Delete right there. And look at that, we're able to add items to a database, new task, add items to a to-do application, do something right here, you know, write code. We've already removed the write code task, write code, and then we can mark as complete, we can delete. So this is creates for adds, reads. Be able to get a data, we're able to get the data from a database. We're able to read it. Update, we're able to update the status to either true, completed as true or false, and then we can also delete. Now there are other things you can do with Dexie.js in terms of query. For example, we can use the where method to filter the items. So if we come to line 16 right here where we have all items, we can do something like this. To-dos, we've already gotten to-dos from TP, to-dos dot where right here. So we want to get all the to-do items where completed equals true, and then we want to get this as in an array format. Well, we have a problem here though. True is not a valid key. So booleans, null, undefined, and objects are not valid keys in IndexedDB. So we can't use true right here. So dot equals, we can use a boolean right here. We can only use strings or numbers. Now with our current implementation where we're using boolean for completed status, we're not going to be able to use true. What we can do instead is use JavaScript to filter our data. Like we can have something like this called completed right here, called completed items is equal to all items dot filter. So all items dot filter, and then we have item, and item dot completed equal to true. So with our boolean implementation, this is better for us, but we can also just use strings, you know, or numbers. So it can be 1 or 0, and then we can do this. So dot equals either 0 or dot equals either 1. And then for toggle item, we have to either we have to use either 0 or 1 to toggle the completion status of each of our items. So you can use the where clause. I'm going to leave a link to the Dexie documentation in the description of this video. It's very detailed and easy to understand. You see other use cases for the where method, which you can use to filter data in the database. And that's it for using Dexie.js IndexedDB in React applications for data storage, for offline storage. I have tutorials on making your application, your React applications, or normal HTML, CSS, and JavaScript applications work offline. And if you're able to make your applications work offline, Dexie.js IndexedDB is going to come in very handy, because even while you're offline, your user is going to be able to use their application, use their to-dos, which is ideal. To-do applications are supposed to be used offline so that they can access data from the database, they can add data, edit data, read data, and all that without access to the internet. But without that, without your application working offline, IndexedDB, Dexie.js have so many use cases like what we've just demonstrated today. And that's it for today's tutorial. I hope you've learned something. I only hear from you in the comment section. If you have any questions, if you have any comments, if you are successfully able to follow this tutorial, and if you are able to build this along with me, please share it in the comment section below. Share the URL to your application, the GitHub repository, or the live URL. I'd love to check it out. All right. See you next time. Bye.